Hey everyone, thanks for joining us again for another webinar. It's going to be a similar subject to last week's, but with a different take, and hopefully you guys will all find some value in it. So this is me. If you're interested in following me, please do so. I'd be honored. Those are all the different social media avenues. I am the founder and CEO of Red Pill Analytics. We've been in business for about almost 6 years, excuse me, with offices in Minneapolis, Atlanta, and Wilmington, North Carolina. Just a little bit of, sort of the price of doing business. You got to hear me pitch about our company for a few minutes, and then we'll get to the good stuff. But the main way that we engage with our customers is something through what we call elastic delivery. And that comes in a couple of different flavors. First off, what we call elastic crew. And you can think of this as an autonomous team that has all the skill set and capabilities to deliver whatever it is you need delivered in the world of analytics, whether that's data engineering, analytics, analysis, strategy, or all of the above. We put a team together with just the right size, with just the right skill set for you to be able to hand us requirements with very little hand holding. And we deliver those requirements in a sprint-based fashion, in an agile fashion. At the end of each sprint, we do retrospectives. We show you what we've built. You guys check the boxes and say, yeah, we love it. And then hopefully you pay us. And that's crew. And this comes in a lot of, we have a lot of different customers, scenarios where we do this. In some cases, we have replaced the customers' analytics and BI teams. Some cases, we work right alongside them, solving different requirements or perhaps working with different areas of the business. And that's crew. And then surge is a little bit more in the traditional sort of project delivery, where we just enhance your team. So we like to call it surge because we think there's value in you, surging 20% of your team to us. We have the ability to change resources, change skill sets each sprint or each milestone, however you guys want to think about it. And so we give you the flexibility that you don't quite have with full-time employees or contractors. So that's why we call that surge. So give us surge 20% of your capacity to us and let us help you deliver data and analytics. And then just these are the tools that we use. Those of you that have been following Red Pill for a long time know that we started in the Oracle world. And we're still very much in that space. It's just not the only thing we do. So these are a lot of the different technologies we use. If you're interested in hearing more about this or how we work with these technologies, then please reach out. And I'd love to talk to you about that. So this is called All I Need Is SQL and a DAG. And some of you who don't know what a DAG is have a lot of confidence in me to deliver a decent talk. So thank you for coming along. I'm not sure this is the best title I've ever written, but it is a talk that I enjoy quite a bit. We all know what SQL is, structured query language, but what in the world is a DAG? Is it this? I don't know if you guys like this movie. I love it. You like DAGs. And this is, anytime I say DAG or hear someone say DAG, a little bit of me thinks about this movie. But no, this is not dogs or DAGs. What we're talking about is something called a directed acyclic graph, okay? And if you really want to think about what that means, it's really a graph of dependencies. So a graph is a way to model or describe a collection of dependencies and how those dependencies flow from one side of a graph to another, or really not really from one side, but from one point in a graph, from the leaf nodes all the way through the graph with a single set of directed dependencies. Hold on, there we go. And I'm not going to read this. You guys can read it, and I mostly put it there for the recording if people want to watch this recording later. But in general, when you define a series of tasks, and those tasks can be anything. So there's DAGs used in build automation and continuous integration and data pipelines and robotic process automation, and all of these different ways that you can describe a process from one end to another. It's made up of smaller units. Usually, we think of as tasks, and those tasks will have dependencies. And so when we talk about how we compare what a DAG is to some of the traditional ways that we've orchestrated data pipelines or ETL processes or workflows and mappings, or whatever paradigm you've worked in, or process flows, whatever sort of paradigm you've worked in building data pipelines, it's a really different way of thinking. And it's, this talk is about several things. Some of it is about getting back to SQL, which if you saw my talk last week, I was also talking about getting back to SQL then. But and there's a lot of value that having a SQL-based data processing or data pipeline can give you. And I want to highlight those this week as well. And I want to show you the value specifically of a tool called DBT. But anything that sort of takes this, what I want you to really take away this week is the idea of what a DAG can do for you. I hope you love DBT. We really do. And I hope it gets you thinking about different ways you might be able to build ETL and data engineering processes. But this week, I really hope that it's the DAG that we sell you on this week, which DBT does use. And that's why all of this sort of ceremony around the DAG is important. And hopefully you'll see that in a small-ish demo that I'll do later in the talk. Another important thing that Martin Fowler is pointing out here is that, several processes may have the same dependency on another task. And one of the powerful things that the DAG does, or the graph does, is ensure that thing is only run once, right? So when you define a process end to end, and you've got several of these downstream processes that all depend on upstream processes. In orchestration layers, that's very difficult to build manually. But when you just define dependencies and let the graph do its magic, then you don't have to worry about things running out of order, things running multiple times. That's really what the graph does for you. And I can remember some, studies years ago when I was working primarily in traditional ETL tools, that there was sort of a movement even then, way back then, before big data, about how you could effectively knock 90% off the time it takes to load a data warehouse in general by just using dependency management. And so the DAG really supercharges that. So one of the things that it may not be completely clear to you as you watch this, the DAG's great, it's easy to build, there's almost no effort in it. And there's no time and effort building orchestration layers and trying to manage those. But also the performance gain that you get from it is staggering. So even if you run the same 100 mappings, but you remove traditional orchestration of, start, wait, remove that sort of heavy-handed orchestration and just go to a DAG, with zero modifications to your mappings, you'll typically save 50 to 90% of processing time by just eliminating the gaps in your processing. So let's move on. So sometimes when people try to draw DAGs or graphs, the arrows point in different directions. So sometimes they point in in the direction you're heading, and sometimes they point back to the thing that you depend on. In this case, this is pointing back to the things that that you depend. Well, now let's see. It's difficult to say here, but sometimes the graph's drawn with arrow pointing to the thing that you depend on, and sometimes the dependency is pointing forward to the thing that can move after it. So, you know, I grabbed this image today and I just can't decide which it is. So, you know, vote. Do me a favor and vote in the QA and let me know what you think. So some projects that use a DAG, okay, you may or may not have heard of some of these. I think Spark, most people have heard of. So when you write a Spark process and you build a Spark process, it has a built-in DAG. So as you start to define the things inside of that data movement process, it starts spinning things up in a graph and declaring dependencies and managing that for you. Apache Beam is a similar project to Spark. You can always get yourself in trouble by calling two things that people are passionate about similar, but in general, they are at least, you know, close cousins in the way that they use batch and streaming processes and distributed platforms in memory and a DAG to allow you to build end-to-end data pipelines. NiFi is similar, but NiFi is a graphical tool-based, graphical data pipelining tool that you build in the browser, but it also has a DAG, so you can declare dependencies there. Tez, I've heard of Tez a bunch and never touched it, but I needed to fill up a little bit more space on the slide, so I threw Tez in there. And then, of course, Apache Airflow. A lot of people have heard about Apache Airflow. And if you really boiled what Apache Airflow is down to really what it is and why it's valuable, it is the graph that it builds of dependencies. So it also gives you the ability, we'll be seeing how dbt uses a graph, but dbt is for a reasonably small use case, right? It's for SQL-based workflows, whereas Apache Airflow can do SQL-based, but you can also, in one graph of dependencies, declare SQL-based processes, non-SQL-based processes, command line utilities, code-based, Python, Scala processes. It's got plugins to a lot of different things. So why aren't we using Airflow? Because dbt is just dead simple. If you want to write SQL-based processing, it just doesn't get any easier and more efficient. You just write SQL and you just go. So, you know, if you have some broader use cases, Apache Airflow might be for you. We see a lot of customers use dbt for their SQL-based stuff and then extend it further with the Airflow. So it's up to you, but you can do SQL-based processing with Airflow, but we're big dbt fans, and I think you'll see why. And then finally, Gradle. So Gradle's a build tool. I've written a lot of Gradle plugins. I've used Gradle to build a lot of software. It's also, Gradle's the heart of the Android Studio. So when you use Android Studio to build Android apps, it's Gradle underneath the covers. That's doing all that. And Gradle also powers a lot of our products, such as Checkmate. So Gradle is, but it's got a dependency graph in there, but instead of it being data pipelines, it's build processes. It is, compile this jar, run these regression tests, publish this artifact to a repository, check out source control, whatever. So Gradle, instead of this being about chaining dependencies together, about moving data, Gradle's more about just building things, building code for you, building software, really. So if you sort of compare, I hope we're a Matillion partner, so hopefully Matillion doesn't take this the wrong way, but And Matillion has its place. I should just say that in case anyone from Matillion's on. But this is a traditional orchestration. And I got another slide coming up of Oracle Data Integrator and how it sort of does traditional orchestration. And if you think about what's different is, yes, we may fan out and parallelize processes, but in these orchestration tools, we always end up coming back to a wait point or a serialize or a, combine a couple of processes before moving forward. And what happens is, instead of you moving as fast as you can, you're actually moving as slow as you can. It is the weakest link. It is all of your processes may finish, and yes, you're running some of them in parallel, but they all have to wait in that group until the slowest process completes. And what we really want to do is have things execute as quickly as they can. The other thing is that I don't know really how to gauge it, but over the years, if I were to try to compare the amount of time in traditional ETL tools it took to actually build pipelines or mappings, whatever you want to call them, interfaces, and orchestrating those things, I think it's equal. I think it was almost as much time spent orchestrating it. And what you'll see hopefully in the demo today with DBT is that you spend 0 time orchestrating it. Absolutely 0. And everything executes as quickly as it can. And if there's nothing else you take away from today, and you still want to use your traditional ETL tool, find a way to introduce a graph, right? Go get yourself Apache Airflow and write a plugin to call whatever API you can call from your ETL tool. And you could get the most performance gains just by orchestrating with the DAG. So if you think about, what we used to spend so much time doing in this orchestration layer with error handling and all of that, it's just it's a waste of time, and hopefully you'll see that today. And then this is tried to find a really good. I didn't have access to a lot of the ODI repositories I've developed over the years because I had some really good load plans that would have really demonstrated this. So I had to go, to the internet and find one. But this is I think this is BI apps. I'm not sure. But in general, what you're seeing here, and all of these are serialized processes. So in ODI, if the two things are pointing up and down, then everything inside that group is parallel. There's nothing parallel in here, but let's imagine some of these groups are parallel. And then also, each of these are scenarios which inside of them, I believe those are packages, have other additional sort of workflows. So if you think about all the time spent waiting for all the individual components of this and this and this and this and this and this, all those individual components to finish before we move forward, that's where you're just losing wall clock time. You're struggling and suffering, and this is why we see 4, 5, 6, 7, 8 hour load windows, and some of that is because they're probably still on-prem systems, antiquated hardware, antiquated architecture. But even on those systems, you could squeeze, you could get 50% of your life back just by orchestrating with dependencies. So now we're looking at, this is generated by DBT. So DBT shows you the lineage. And this is very much with the arrows pointing to where they're going. So the demo I'm going to do today is from a data set that is a lot of open source projects from GitHub. So pulling all the commits and files and all that from GitHub. I was tired of a lot of the other things that I'm used to working with, and I just wanted to do something different, and actually it was a lot of fun. So in this scenario, we have some sort of staging, source tables and staging tables, where we go and we pull, in this case, a data set for commits. We have a data set for mapping licenses to like is it Apache, is it new 3 or whatever, mapping those to repositories, commits map to files, files map to file contents, and then you can see that we go and we load. It's a small sample, but hopefully it will get the point across. And we can see how this graph, if you ever look at real production DBT graphs, they're mind-numbingly big. And all of that, it just manages itself. And we'll see how it does that with the dependencies. The dependencies are really easy to manage. So this is the graph that we're going to be working with. And this is the, I'll show you how I built this, and we'll execute it and see a lot of what DBT can offer us. One final thing I wanted to say about DBT is if you're coming from a traditional, and let me reset here for a minute. So we're looking at DBT. We're also looking at just, DBT is our example of a graph-based dependency execution tool, right? So there's two things to keep in mind. One is, let's talk about DBT because we're partners and we love it. But let's also talk about the aspect of DBT that is just a graph tool. And I want to make sure we sort of focus on both things. Right now, I want to talk about what DBT is and isn't. And if you think of sort of the ETL world and the ELT world, I think we've all lived in this ETL versus ELT world long enough to know what that means, right? So for years and years, we had, traditional ETL tools that did all the transformations outside of the database in a big, thick third-party tool, and all the transformations were there. Then we moved to what we call pushdown, where the ETL tool could, push a lot of the logic down to the database, which it's really good at. A database is really good at crunching data, better than a, thick client application, I would argue. And then you had some tools like ODI, which actually ODI is ETL or ELT, depending on which knowledge module you choose, right? You can choose a knowledge module that is array-based and all the transformations occur outside of the database. You can even use ODI to load things that aren't databases. You can load web services and create files and all those things. So it's sort of a misnomer to call ODI an ELT tool. ODI is a data integration tool capable of doing ELT, kind of its default position is ELT, but also capable of doing ETL. So I think we've probably been in this, paradigm long enough to understand the difference. What I want to be clear about is in this new sort of modern architecture, we're not just debating about whether the tool is an ETL tool or an ELT tool. What we're talking about here is actually splitting the ELT up into right tool, right job. DBT does not bring data into your data warehouse. It can in certain circumstances with external tables, but it has no power to get files loaded into object store so that you can run them in BigQuery or Snowflake or whatever it is you want to run it in. So DBT actually, and they don't apologize about it, because what they do is they focus on the transformation, and they do it really well and really easy. And you're going to have to partner up with something else to bring that data into either your data warehouse, into your data lake, or wherever it is that you're going to have DBT process. So again, unapologetic about that. They focus on just the transformation. So bear that in mind. So when you see me building DBT models, executing DBT models, testing DBT models, it's DBT only operates on data that's been landed in your SQL warehouse. And actually, when you try to find an ETL tool that does all of that, if that is something that you absolutely believe you need to do, what you're probably going to find is a tool that doesn't do either one of them, either the replication or the transformations very well at all. right? So it's lowest common denominator. So one of the main things in our strategy sessions with customers today, and our modernization approach that we take with customers today, is, we don't always rip out the ETL tool, but we often do. And what we replace it with is not a tool, but probably a collection of things that are best of breed in what they do, whether that's replication and something like Fivetran, transformations and something like DBT, or transformations and something like Databricks. So I just want to make sure that that's understood. After I do a demo of DBT for the first time, if I haven't been clear on that, a lot of one of the first questions I get is, well, how did you get the data into the data warehouse? And it's just something that DBT is not concerned with. Not to say it's not important. It's just not something that they handle. So if you missed my presentation last week, I looked at the registration list here. It looked like we were maybe 30% were on the webinar last week. I think it was a rough swag estimate. But what I did in that talk was I sort of debated code versus clicks. I got just a couple of slides from that presentation. I didn't want to bore the people who watched both, but I do want to say that I'm not going to really debate code and clicks here today, code versus clicks. I'm not going to debate whether you should be writing SQL or Spark or whatever it is you want to write versus clicking and dragging to do pipelines. We're seeing a lot more of the former. Obviously today, you're going to see me write SQL to do an end-to-end process, very much in the code world today, not the clicks. But I'm not going to spend a lot of time trying to debate that. So there's the link to the video. It's public, and you can watch it. And if you have any questions about that, because perhaps you missed it last week, please reach out to us, and I'd love to discuss it with you. But I actually, half that presentation is about why you might want to think about using code today instead of graphical tools. And so if you're interested in sort of rehashing that, please have a look. There's just a couple of slides. Those of you that saw last week, bear with me for 5 minutes. For those that didn't, I really want to just make sure that you go and if you're interested in maybe retooling, thinking about code again, thinking about SQL again, what it can do for you, then I really urge you to go read this article, Rise of the Data Engineer. It's a really great article. Maxime comes from traditional ETL. He's not one of these data engineers that never lived in the worlds that I spent so much time in, and a lot of my colleagues did. So he definitely transitioned, and because of that, he has an appreciation for where he came from, but also a definite stance to not do things that way anymore. So I would just really urge you to read that. It's a really good read. And then there's this one quote that I wanted to pull from it, which is that, at the end of the day, and I'd love to talk to any of you about this when we have more time, reach out to us, but I will, talk you through why you might want to be thinking about coding again. And there's a lot of great reasons to do that. And the main one is, and this is the last slide from last week, which is, sorry, I spoiled the surprise. I buried the lead. So in general, when you're using these traditional ETL tools where we think that, oh, it's click and drag, it's graphical, it's so easy to use, but every time I've ever done this or seen any other developer do this, that's not the only window they have open. This is the other window they have open. And that's because the really hard work they're doing is in that SQL editor, right? They're testing granularity, testing joins. They're finding out how data can be loaded, what kind of transformations need to occur, and all of that is being done in SQL. And then inevitably we go back to the graphical tool and try to represent or redevelop, if indeed clicking and dragging is development. We try to redevelop that SQL in a GUI tool. And what I'm would like you to start thinking about, it may not be for everyone, is why not just do the SQL? Why not find a platform? There's a lot of SQL-based approaches today, in not just relational databases, but in distributed data platforms, big data, everything speaks SQL. So if you're really thinking about, how could the world maybe change for you in a better way, if you know SQL and your team knows SQL, then investigate some of these platforms. Definitely investigate DBT. And really, we aren't starting with a blank palette, blank slate, I should say. This is absolutely the last slide from last week. So, and I think what those of us that sort of hand-coded data warehouses 10, 15 years ago, we'd roll up our sleeves, especially if we were first on a project, and there's nothing to use. Everything had to be written from the ground up. And now there's tools like DBT that just make it simple, make it so easy where you just code your SQL, and it handles even manifesting that SQL, persisting that SQL, generating incremental loads from just pure SQL statements, which you'll see. So it really is adopt a framework. Don't start coding with no framework, but adopt a framework that really makes it easy. And with that, I'm going to do a quick demo here. So I'm going to stop sharing that, and I'm just going to share my editor for a minute. And then we will come back, hopefully. Come back to the browser in a minute. So you see my SQL script called fact commits.sql. Yes? Anyone? Yep. Mike, Lauren, just come on, help me out here.
Yes.
Sorry,
Yeah,
I didn't know I was on mute. Yes, I can see your screen.
That's fine, great. So there's two ways to develop in DBT. There's open source DBT, and that's mostly using whatever editor you like, and a command line utility called DBT. You guessed it. And I'm going to show you just a little flavor of that. But then also there's DBT Cloud, which gives you a browser-based development environment, not click and drag. It is SQL, but it gives you a lot of nice wrapping around that SQL, and it makes it really easy for you to execute SQL and then execute just SQL to see your results, and then sort of add that to your flow. So we'll see that. But I did want to just kind of let you see what it looks like to use the open source command line and editor-based development. Now, a lot of people who use DBT Cloud still develop this way, actually, and they prefer it because DBT Cloud is the online editor for if you want to develop in the browser, but it's also a back-end runtime execution layer. So if you're from the world of ODI, think of it kind of like your agent. So their cloud service offers that. It also offers the integration with Git and integration with pull requests and all the kind of stuff that you want to do Git ops and data ops in today's world. So that cloud service manages all that. So you don't get any of that if you don't buy DBT Cloud. So I'm just going to show you both sides. So in general, when you look at a DBT project, you are looking at kind of our starting point is this DBT project. And this is sort of the heart of your DBT project. If this were a build tool, this would be like your build file. If this was a CI/CD server, this would be your pipeline job file, whatever you want to call it. So this was your Jenkins file or your Circle CI YAML file or whatever you want to call it. This is the heart of your build. And so what we do is we define a few things. Okay, so the first off is a profile. I have a profile.yaml file in my home directory where I've defined some connections. And I can just use one of those connections for my development experience. I can change that too, but I'm just calling out a profile there. And in this case, I'm doing all this in BigQuery. I did Snowflake last week, sharing the love. Also, BigQuery had the GitHub public data set where I didn't have to do anything. So it was really nice. So I have a connection in a YAML file, and I'm just using that connection. No username or passwords in that file because Google Cloud's really, really great. It's a key. It's it's a JSON file that has SSH key information in it. So it's just a key, not username and password. We define some of our default places in my Git repo where I'm going to put things, right? So the biggest and most important one is my source paths, which is models, right? So inside of my models directory, I have some stuff, right? A bunch of SQL files. And so I've defined that that's where you go to look for models. Analysis, I'm not going to show you today. Maybe I'll have a follow-up webinar where I'll show there's DBT makes it easy for you to, instead of move data, it does all the data engineering and data movement for you, but it can also help you prepare sort of an analytics layer for tools like Tableau or whatever who don't have that sort of power. Test paths, if you want to write some custom tests, regression tests, unit tests, whatever you want to call it, that's where we put them. I don't have anything in there because I'm using the schema.yaml, you'll see it, schema.yaml file to define my tests. I'm using the built-in sort of test framework, but if I wanted to just write SQL scripts and put those somewhere and have them defined as tests, that's where they'd go. The data paths, if I need to seed data, like, I don't know, for regression tests, you want to write a CSV file of all the interesting data anomalies that you've experienced and make sure that your regression tests can run that in conjunction with live data, right? Regression tests can run live data, but they can also read some of these file formats and run through known data anomalies each and every time you write, make changes to your pipelines, to your your data engineering code. You can make sure that those, in case those paradigms you want to test against may or may not exist in your real data, but they may not exist today, doesn't mean you won't get them tomorrow. If you want to make sure you get coverage on those anomalies, you can actually write data files and test against them. Macros, exactly what it sounds like, reusable bits of code go in there. And then snapshots, it's a really strange name for slowly changing dimensions, but that's indeed what it is. You're not going to see any of that today either. It's really some simple transformations. Just imagine that on top of all this, I took it one step further and built the snapshots instead of just loading sort of non-SCD tables. Target path, that's where, the concept, DBT has the concept of the code you write, the compile code, and then the run code. The code you write is just select statements with sort of some config and placeholders in it that gets replaced with things when you actually compile it. And the compile it makes that select statement executable, right? So the statement you write with some of the reference, you'll see it, isn't actually executable because you're dropping some breadcrumbs, mostly around dependencies. So DBT compile, let's just do that. DBT compile, that's sort of the first thing you do, and a DBT run does that by default, and that builds and does sort of the replace of all those variables and placeholders with actual values and gives you a runnable select statement. The run version that DBT generates, though, is not just the select, it's the create table as select, or create view, or merge into, or however you've configured materialization, as it calls it. All you have to do is write the select statement. It handles everything else, and you'll see that. So you don't have to write create table as select, insert into, merge into, or whatever. DBT handles generating the wrapping around your select. One of the things I really, really like about it is I just write selects. That's the way I think. That's all I have to do. So I'll do a DBT test quickly. And this is running any of the regression tests that I've configured. You're going to see this in a little bit more detail when I jump into the DBT cloud service, which is a browser. But in general, I have defined in these schema.yaml files my tests on individual columns, individual data points. And so every time from now on, when I reference that model in a pipeline, it's going to run these regression tests. And if I build new models, it's going to run these regression tests anytime I do DBT test. I can also test just particular models, DBT test, and I only want to test my DW model. I can do that. So I don't want to run all my tests. I just want to run a few of my tests. That's good. I can do DBT run the same way. So DBT run is how I actually execute if I'm not using the cloud, right? So if I'm using DBT cloud, the cloud service kind of takes care of this for you. But if you're running just using the command line utility, I can do a DBT run. I can also define the model that I just want to run. Let's just run the source model, which is this one. It's going to run all that. And notice I have 1, 2, 3, 4, 5 models in there, but it's running 3. Why isn't it running 5? Well, because it knows about the dependencies. It knows that these 3 things don't depend on anything. So if we look at them, commits is just a great little SQL statement. No magic in there. We look at languages. Languages is also just a nice little SQL statement. And then licenses. License is also a great SQL statement. Why did we have to wait on files? Why didn't it run files right away? Because files has a dependency. So this is how you define dependencies inside of DBT. Instead of saying from table whatever, I say ref commits. It knows that this is commits, and it knows it depends on that table. It's just as simple as that. So when I run DBT compile, DBT gives me a version of this files.sql file where it's put in the placeholder. And then when you do DBT run, it actually takes that compiled file and generates a materialization strategy. In this case, we're everything in the, I know I'm jumping all over the place, try to bear with me. I'm defining my materialization strategies here in the different models. So I've said my default materialization strategy is table. That means create table as select. So when it comes time for you to execute that model, I want you to create table as, and then sort of put in the select statement. Other materialization strategies are incremental. Incremental can take different flavors depending on the target data warehouse or data lake platform. But if you're thinking about BigQuery, Snowflake, SQL data warehouse, or all those things, it typically is a merge statement. So what you'll see when I do the DBT run, which is the whole thing, and actually, yeah, we'll do DBT run. It's going to run those tables again, so bear with me, sorry. So you'll see it run these again, and those are all create table as select. But when we get down to anything in my data warehouse model, and you can think of this as my star schema, this is the layer I'm building and delivering to an analytics tool or a BI tool. I want all of that to be built incrementally, right? So it's up to you. I should have done a slide with idempotent. I don't know if you guys know what that word means. It's a very popular word in modern streaming architectures. It just means that you can run the same thing. If something's idempotent, it means you could run something You can run it over and over and over again, and you won't change the results. And a lot of modern data architectures try to be idempotent for a couple of reasons. We have all the data usually in some sort of a data lake, so we can then, cache that data in our data warehouse. We don't really need to do change detection as much as we used to. And also just processing all the rows every day is, especially if you're doing it in a staging layer building up, is not usually all that unreasonable in today's architectures. But it's up to you. We can still do incremental loads at every layer if that's what you wanted to do. But basically, my source layer is idempotent. My staging layer is idempotent. Those are just CTASs each and every day. And then my data warehouse layer I've defined as being incremental. And that's this materialization strategy is incremental. The other materialization strategies are view. That means just create a view to hold all this logic. That might be beneficial for some folks. And then also what's called ephemeral. And that just means take this logic and push it down to the next layer and push it down so that the select starts growing. Any of these options are yours. You can see that when I loaded my dimension tables, I did those with a merge. And when I loaded my fact table, I did that with a merge. Also notice that I'm not doing this in the, I'm doing this in my own BigQuery schema. And that's the other thing that idempotent makes it really nice, is every developer can define a different place to build out their models as long as they're all coming from the same place. So developers are not stepping on each other in a shared dev environment, trying to run mappings. They're in their own sort of insulated place. And just by pointing to a different profile, I can change where I run it. And what you'll see as I do some of the, I need to get moving quickly. I'm gonna do a pull request based development. You'll see that dbt Cloud actually builds your pull requests in a completely temporary spot, which is really nice. So I'm running behind. Let me jump over here to, let me share my browser again here. So this is dbt Cloud, okay? So again, if you were hoping for a click and drag tool, you're probably not very happy, but it does give you quite a bit of functionality. So it gives you the ability to run your models very easily, right? So I have this source model, and I have one of my sort of base SQL scripts is this commits. That's the first table that goes and grabs commit data from that public data set from GitHub. And so I can say, hey, I just want to run my SQL. Oh, no. Just want to run my SQL. And I can quickly see my results. Now, this is I probably should have chosen another one because this one takes a while. I'm actually doing some sampling in this table to decrease it's hundreds of millions of rows. You can see I'm just sampling. But I can actually run the query here and see the results. This is the wrong query to run. And of course that cancel's not going to work, is it? There we go. Okay, let's pick a different one a little bit easier. Let's try licenses. Come on back really quick. I might be having an issue here. Bear with me 1 second. Looks like it's actually running. Let's verify that. That's not actually running. Yep, I'm going to do the help desk thing. All right. Let's go into my source models. Let's try languages, for goodness sakes. Hey, all right. So this is just so you can see that I've written my SQL file and I can actually execute it here. So instead of me in my editor writing a file, writing SQL in a file and then going to a command line utility and saying dbt run, I can actually see the results here and work with it. Now BigQuery does, and sort of Snowflake has an editor, SQL editor that I could use. But what you'll find when you start using dbt Cloud is that it's a really nice integrated environment for you to be able to run your SQL and test. And then if I indeed am using something that has these ref commands, I'm trying to pick which one will be fastest. Let's try this one. It will go ahead and compile that SQL for me. As you'll see, the compiled SQL, right? So I don't have to copy paste out to an editor. Simple enough, right? I mean, it really makes it very, very nice. And then also all those dbt commands that I'm used to doing, I can do right here. So if I want to do a dbt test, I can do that here as well. A little bit better screen for it, I would argue. You can see all my tests are running. I can also do a dbt run. Let's just do one model. And I can see it's very similar to the command line utility, but with a little bit, I would say a little bit more interesting throughput, screen, real estate, all of that. So we can see that my processes are running, hopefully. There we go. So that same sort of behavior you had from dbt in the command line, So, you know, that's really nice. Now let's go ahead and let's make a change to something because we're going to open a pull request. So let's say, it doesn't really matter what I change, does it? Let's just change. This is my schema.yaml file, which is where I can define some tests. And I can also give some breadcrumbs for documentation. It generates some documentation at the end, which you'll see. So all of these sorts of descriptions and things, that's feeding information into the documentation later. It's kind of like a Java doc. Let's just, so as soon as, you know, it detects that I have some changes, it says, hey, do you want to commit this? Yeah, added almost nothing. And we'll commit that. And as soon as the commit's done, you know, I forgot to change branch. All right, let's create a new branch. Any of you guys see that happening as I was doing it? That's what I was looking for. Yeah, pull request. Awesome. And so I'm going to create my pull request. And there we go. So give it just a second. You'll see DBT kick in, DBT Cloud kick in. You'll see DBT Cloud kick in. You'll see DBT Cloud kick in. There we go. So you can see the details there, which takes us right back to where I was if you want to go to it that way. And you can see, hopefully this thing starts running. So Mike, do we have any, while we're kind of waiting for this to kind of execute, do we have any questions?
Yeah, we do have questions. We know we've got about 4 minutes left here in the session here.
Let me get you to pause 1 second, Mike, because this is what I wanted to point out.
Okay.
So, so when you configure to test pull requests, it creates a temporary schema in your Snowflake or your BigQuery database to run all that ETL for you to be able to test against it. So that you're not actually touching anything. That was it. Go ahead, Mike.
All right, so our first question comes from Marty. When it comes to modernizing our data warehouse and analytics, outside of using dbt, how can we build and use a DAG?
Yeah, so Marty, I'm going to assume maybe you have something traditional, like let's just, for argument's sake, let's say you've got ODI or Informatica mappings. Those things have APIs, or at the very least, a command line utility you can call to execute mappings, right? So I'm gonna, you know, whatever, I don't care how old and decrepit it is, there is a way to call a mapping from outside of your ETL tool, outside of your ETL scheduler. Use something like Airflow if you're gonna go that route, because Airflow has plugins to a lot of things anyway. It's got plugins for a lot of known things. The community's written plugins so that you can create a DAG in Airflow. So if you're going to try to run a bunch of things that that were developed elsewhere and there's no real connective tissue between any of it, Airflow can easily become that connective tissue. If you're starting over and want to start writing SQL, Airflow can do that as well, but it's not near this easy. It's not near this streamlined, and it's not near this, I'm going to say it, enjoyable. I enjoy writing data transformations in DBT. Airflow is a little bit more heavy-handed, but it is a Swiss Army knife. You can execute anything with it.
All right, thank you. And then you kind of touched upon it here. So the next question from Cynthia is, it says, we're a legacy Oracle and Teradata shop, no inkling to modernize in any way, shape, or form. We use Informatica. You know, how can we use DAG, knowing that they're, we'll say, the old school legacy?
Yeah, I think it's a similar question. So I'm not as knowledgeable on how to put wrapping around Informatica as I am with how to put wrapping around ODI. But there's a Java SDK in Informatica. I know that. You can execute mappings using that Informatica Java SDK. A lot of the Airflow, I'm going to go back to Airflow because it's a great tool. Airflow is written in Python, which means it's easy to interact with Java, Scala, and all those sort of JVM languages. So you could easily write a wrapper. There probably is one already, I don't know, but Airflow has a plugin architecture. So instead of you having to do the same thing over and over again with each mapping, you just write the plugin for the placeholders for all the different parameters you need to pass to that SDK. And then each time you need to execute a mapping in Airflow, you just have to pass in the parameters such as mapping name, parameters that the mapping is expecting, etc. So yeah, same answer. Go if you're gonna keep it, go look at Airflow.
Okay, perfect. Thank you. And then one final question. We know we're at the top of the hour, and we're gonna have to jump off. This is from Julie. And do you feel there's a movement amongst other vendors to implement DAG into their tools, or is this left up to each individual company to figure out DAG?
Yeah, I think so. If there's anything we'll just call it modern. I don't mean that as a negative to the older tools. I just mean that they're relatively new, right? So they've grown up in the world of distributed data. That data is distributed across a bunch of nodes or even serverless, as opposed to all SQL and data being processed inside a single node. So these modern platforms all have DAGs. Almost all of them have DAGs. So if you were to choose a platform, that is 5 years to 7 years old, and it's for building pipelines of almost any kind, it probably has a DAG in it. If it doesn't, it connects to Airflow. So, and this is a talk about DBT, and I've been saying a lot about Airflow. DBT is great if you want to start writing SQL, you want to port your ETL tool, legacy ETL tool to something easier, more manageable. DBT is for you. It's so much easier. If you're going to live in a world where you've got a whole bunch of things from legacy worlds, scripts, combinations, maybe PL SQL as well, or whatever sort of language you have, you can write a plugin for all of those different things and execute it from Airflow. Airflow is the connective tissue.
Okay, well, perfect. Well, let's kind of draw the line in the sand there. Apologize if we didn't get to your question, but appreciate everyone joining us today. Thank you, Stewart, for leading us through this session here. Definitely very, very informative.
So, hey, Mike, for those people that are still here, I know I may have lost a few of them. I just wanted to show that in my pull request workflow, I defined, hey, I want you to run with the full refresh historical and the incremental. So I test both of them with each pull request. So I make sure that I can, in different schemas. So I can make sure that if I ever have to run from starting from zero in an idempotent process, I can, but also I'm testing my incremental process. With that, Mike, if you want to take us home.
Yeah, absolutely. So thank you everybody for attending today. Thank you, Stewart, for leading us through the great discussion here and topics. Definitely very, very topical and top of mind of many folks out there, and for others, they're just getting their feet wet. So definitely very helpful, and thank you everybody for joining. Within the next day or so, we will send out a rebroadcast of this so you can rewatch it or forward it to other colleagues. So thank you everybody. Have a good rest of your day, and we'll
stay safe.